Okay, ladies and gentlemen, let's start plugging away. We still have a couple more sections to talk about, and they really aren't that intense now that we've already covered sine, cosine, tangent, and their applications as far as trig functions goes. Alrighty, so section 6.3, well, guess what it deals with? Oh, trig functions yet again, um, but and with right triangles, but this time we're going to start talking about things that expand outside of the unit circle and how we shrink it back in. Right triangles. Okay, so this is just basically another concept that's underneath it. Now, this is the good news. Okay, this is the good news. If you know this, so here's something that's kind of cool, and I'll put it all together. We've already determined the unit circle is built off of a sweeping hand, okay, and a turning angle. So imagine this hand sweeping like Doppler radar, and it goes to a certain point. So we'll say this is the hand and where it's at right now. This angle that it's sweeping, theta, is the radian of measure. The hand, though, we call that a radius. And then if you notice, the length of the hand lands at a certain point. The length of that actual hand lands at a certain point. This is a point x comma y, and that's all because this is the value of x and this is the value of y. So what we've come to find out, then we know we can find everything out that we need. We can say that the sine of that angle is literally the opposite over the hypotenuse, right? The cosine of that angle, yet again, is the opposite over the hypotenuse. And this basically goes back to how I found all those special values on the unit circle to begin with. Is the x over the hypotenuse, okay, opposite over hypotenuse. But see, now in the unit circle, the radius is 1. So that's why we say the sine would be just y, because it would be y over 1, FYI. So tangent, same thing. Tangent is still sine over cosine. So a tangent of an angle is still sine over cosine, which gives you y over x, right? Y, because no, divide this fraction by this fraction, and you multiply by reciprocal, simplify it out, and you get y over x. Okay, and then they're inverses. So, excuse me, cosecant of theta is going to be equal to 1 over sine of theta, which is 1 over y over r, which is the radius over the y coordinate. And similarly, secant of theta, do the same stuff. Cosine of theta, right, is 1 over x over y, r, which is r over that x. And last but not least, my good friend, cotangent of theta, which is 1 over the tangent, which basically just means just flip the tangent and you end up getting x over y. So this is how it all goes down. On a unit circle, r is 1. R is 1. That's why the sign will be just the x or just the y. And we can expand or shrink these triangles, which is a very, 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 very cool feature. So let's go through a problem, and I'll probably give you this one for notes in class. But this is everything that we've been looking forward to. Okay, so erase this and let's talk about it. So let's say the terminal side. Okay, the terminal side. This is some vocabulary for you. Side, and the terminal side basically means the that little radius or pendulum hand that's sweeping around of an angle theta. Okay, so if I had to draw you a picture, it looks like this. So this side here, this is theta. This would be the terminal side. Okay, passes through 3, -2. So that's 1, 2, 3, 1, 2. So that's this point right here. Okay, everybody with me so far? And now it says find the value of all. I should probably move that aside. Of all 6 trig functions. So good news. I'm going to redraw this on the side here so it looks a little better. So it sweeps out, and we have this. We have this triangle sitting here. If you've noticed, we know this is 3 negative 2. So we know this is 3, this is 2. So we can actually use the Pythagorean theorem to find r, which we need in order to find the sine, cosine, and tangent. We need what r is. So here we go. R squared equals 3 squared plus 2 squared, which is 13. So the radius is the square root of 13. Bingo. So now we know that the sine of this terminal angle theta is the opposite. Now notice this 2 is down. So even though this is a physical measure of actual 2, it's in the fourth quadrant. Cosine, the y is negative here. So this 2 should be a negative 2 as opposed to just a regular old 2 over the square root of 13. Cosine of theta would be 3 over the square root of 13. Tangent would be the sine over the cosine, which ends up being negative 2 over 3. And then flip them all. So if you were looking at their reciprocals, so square root of 13 over negative 2. Secant of theta is root 13 over 3. And last but not least, cotangent of theta would be 3 over negative 2. Easy. So very easy. Excuse me. Okay, so this is if they just give you a point. But what if we gave you a little bit more detail? A little bit more detail. So let's take a look at it. Okay, so let's say I said this. Find all trig functions. Six trig functions. Functions where sine, the y, is negative 4 over 5, and the cosine of theta, what is cosine, ladies and gentlemen? It should be running through your mind, is the x is 0, is less than 0, okay? Now, let's think about this. So think about this, and I gave you a nice handy dandy acronym that I'll draw on this nice little think bubble on the side, and I told you this acronym. All students take calculus, right? And what was the all for? This tells you where things are positive at, okay? So all the trig functions are positive here, sine, cosine, and tangent. Here, only sine is positive. Here, only tangent is positive. And here, cosine is positive, okay? So check this out. This piece of detail says that sine is negative 4/5. Let's focus in on this negative. So where is sine negative? Well, sine's the y. Sine is not negative in the first and second quadrant. Notice it says all of them are positive, right? And why? Because the y is positive here. Sine's the y. So sines are both positive in your first two quadrants. So this is quadrant 3 and quadrant 4. Okay? Those are the two places it can happen. That's a lot still to analyze, and we still need to find all 6. But let's look at this big piece of data. And cosine is negative. Well, where's cosine negative? All's positive in the first and cosine is also positive in the fourth. Why? Because this is where the x's are positive. So they are negative where? In the second and the third. So look at these two. So which quadrant are we living in? We're living in quadrant 3. So that means that our terminal angle theta will stop here somewhere, and this is theta, and it creates this triangle. And we have this point here. Now we know something special. We know that the sine of theta, the sine, if you notice, the sine is negative 4 over 5. So let's think about this. Sine, if the sine of the theta equals negative 4 over 5, right? And there's actually two ways you can look at this. I tend to always look at it as a unit circle just because it makes your life a little bit easier. But some people look at this as what was I going to say here? Some people look at this as opposite over hypotenuse, which is fine, okay? So check this out. If the opposite of this would make this 4. But check it out. Note that it's a negative because we are in the part where the y is negative, and the 5 has to be the hypotenuse. So if you do your Pythagorean theorem, you could find this side. You could find that side, and I'll spare you the details. A squared plus b squared equals c squared. Solve all the crap. You end up getting this is 3. Okay, so now that you have that, you can answer whatever questions they want you to figure out. So what is that? So what is the cosine of theta? Well, the cosine of theta would be the x, which is, note that it says 3 here because I can't have a negative side of a triangle, but the actual value is negative 3. It's negative 3 over 5. I have the sine, which they already gave me, but I could write it again if I would like. Sine of theta has to be negative 4 over 5. The tangent is the ratio of the two, which will end up giving you negative 4 over 5 divided by negative 3 over 5, which is just 4/3. And then you got the reciprocal. So cosecant of theta is 5 over 4 negative. Secant of theta, which is the reciprocal of cosine, is 5 over 3 negative. And then finally, cotangent, flip the tangent. 3/4. It's really that simple every single time. So you're going to determine based off the two pieces of detail where you're living. So this is the big cookie right here. Okay, so really pay attention to that. Let's do, so basically the big thing is let's make sure we can just find where we're living right now. Okay, so here's a couple. Okay, so let's say A, and this is getting a bit long, so I don't want to keep it too much longer. Let's say they say we're looking for all 6, where sine of theta is 2/3, and we're looking for the theta, where we're in between 3 pi over 2 and pi over 2. Notice they didn't give me a cosine that's negative or something. They actually gave me dimensions. So I want you to think about this. Sine is positive where? Okay, sine is positive where? So think about it. Think about it. All students take calculus, so it must be the first and the second, or if you can't see it like that, the y is positive here, so which means that it has to be this quadrant and this quadrant. Likewise, where's pi over 2? So we're talking here. Pi over 2 to 3 pi over 2. Well, pi over 2 is here. 3 pi over 2 is here. We're talking here. So you tell me which quadrant we're talking about in common. And this is just another way of looking at it. So this one is second and third. So the one they have in common is we'll be living in is the second quadrant. So our terminal angle should be here. And they're telling me that this is going to be a hypotenuse of 3 with a y of 2. With a y of 2, you could use your Pythagorean theorem yet again, and we could find the mystery side. A squared plus 4 squared equals 3 squared. So a squared, not 4 squared, 2 squared, sorry, that's already 4, equals 9. A is root 5. But note on this side it's negative. Careful. Alright, so now you can find all your trig functions, and I'll let you do that. What is sine of theta? What is cosine of theta? Tangent of theta, cotangent of theta, secant of theta, and cosecant of theta. At this point, this should be pretty straightforward since you already know what your trig functions are. Alright, so this basically brings us, now I don't have to name all 6, I could tell you just to find one of them, right, just to test your abilities in finding stuff. But this is all there is to 6.3, okay, so it's really not all that hard. And this really is big because this will lead into when we start talking about inverse functions in 6.4 and 5.5, so which we'll talk about at the very end of the semester. Alright guys, I hope you enjoyed. Once again,